Welcome to the second video on the free and open source GODOT game engine platformer series. In this video, we will continue with the same 2D platformer example we have been developing on different game engines. We will create the enemy and its animations, give it some basic AI to allow it to move on a platform, or between obstacles, detect the player and attack it until dead. Let's dive into GODOT. To create the enemy, we will take a different approach for when we created the player character that was directly created on the same scene with the level. We will create it in its own scene that we will be able to import into the game whenever we want. For this, let's create a new scene of type 2D scene. Rename the root node to enemy skeleton. And with it selected, click on the add sign in the hierarchy top bar. In the search bar type in kinematic and click on the option kinematic body 2D and on the button create to add a 2D physic node to the enemy. Click again on the add sign and in the search box type collision. Select the collision shape 2D and click on create to add it to the hierarchy. In the next step, we have made a mistake as we have directly clicked the add button to add a new component, which will be added below the kinematic object. To avoid this, click first on the root node enemy skeleton, and then the add option. In the search box, type animated and then choose the AnimatedSprite option followed by the option create. Now, click again on the collision shape node, and in the inspector on the right side of the window, under the option shape, click on the Dropbox button and select the option capsule shape 2D. Let's create now the animations for our skeleton enemy. In the hierarchy pane, click on the AnimatedSprite node. In the inspector on the right pane, click on the frames drop-down menu and select new sprite frames. Next, click on the selection itself, and it will take you to the sprites animations editor. Let's increase the frame rate of the sprites that we will be using by either using the arrows or just by entering the new value directly in the text dialog. Before we can move forward, we need to import the sprites to be used for the enemy skeleton. So, from the file system, drag into the resources folder of your project the source files for the enemy skeleton. Go back to the GODOT editor, and you will be able to see the system importing the sprites. Let's rename the animation to idle by clicking on it. From a previous intent that went wrong, we have already a frame that we will be deleting next. From the sprite animation top menu, select the button add frames from sprite sheet and then in the new screen, select the sprite sheet that you want to use for the idle animation. Click open to open it on GODOT Sprite Sheet Editor. In the top menu, select the number of horizontal and vertical frames to be used in the animation. In our case, for this particular enemy skeleton we can count 11 frames in one row. You can then click on each frame to add it to the animated sprite or to click on the top right button select or clear all frames, to add them or remove them from the selection. Click the button add followed by the number of frames to be added to continue with the integration of the character on GODOT. Click the new animation button on the left top animation menu to add a new animation that we will be naming walk. Click on the add frames button and select the walk sprite sheet. Enter the number of frames and rows in the sprite sheet, which in our case will be 13 and 1. Select all the frames and click Add to import them into the scene. In the video, we forgot to adjust the frames per second to 12. So make sure you change them now. In the inspector, under the frames option select the idle animation, and then with the cursor on top of the scene view, zoom out until you can see the enemy skeleton. Zoom in again, until you have the enemy on the center of the scene view. Select the collision shape 2D and adjust its size and position to overlap the sprite. You can resize it by dragging the two dots on the top and right sides of the capsule. Save the scene frequently to avoid losing your work, you never know. Select the kinematic body 2D and click on the button to lock the child's nodes and make them not selectable. This will allow you to place the enemy at position 0 of the scene to make it the pivot point of the enemy once imported into the global game scene. To preview how it is looking like, select the animated sprite, and then in the inspector pane, click on the checkbox playing as to switch it on. You should now be seeing the enemy skeleton starting to play the idle animation. You can use it to further fine-tune the frame rate of the animation. Finish positioning the enemy in the 0 position. Let's switch back to the main game scene, by opening it from the project folder, or if you have already it opened, by clicking on the tab associated with the scene. Now, let's import the enemy skeleton. Again, we can do it in different ways. You could use the import button that would allow choosing the new element to be imported, or as we are going to do, by dragging or double-clicking it from the project resources into the scene. Let's run the game to see the results. And not much more happens, as we have not yet created any basic artificial intelligence for the enemy, so let's do it now. Go back to the enemy skeleton scene. Select the kinematic body 2D to guarantee that the script will inherit from the right class. In our case, we had the animated sprite selected, which will for us to refine the creation of the script. Click on the button Add New Script in the hierarchy top bar, next to the search option. Name the script as enemy skeleton or what other name you want. In our case, you can see that we are inheriting from the animated sprite class, so we'll have to click on the Explore button next to the class, and look for the kinematic body one. Once selected, click on the button Create to create the script and add it to the object. Let's add some constants that will be used to control the character. A not vector set to vector 2, x0, y-1. A gravity set to 25. A max speed defined as 50 and a max gravity defined as 50. Let's define now some variables needed to make the character perform the actions we will need it to perform. Which in this case, for the moment, will be a movement vector that will point the enemy in the direction it is supposed to follow. Since we are moving the character with physics, we will be putting all the code in the _physics process. Remember to check the indents as it is what gives structure to the GODOT scripting. Let's call a move enemy function and let's define it below. We will start by calculating the value of the gravity along with the y component of the movement vector, and we will check that if the added gravity is higher than the maximum value of the gravity, and then let's cap it to max gravity. Let's check if the enemy is on the floor, by calling the method isOnTheFloor, that will return true if the enemy collider is touching the ground. In which case, we will set the y component of movement to 0. As to move it, for now, Let's make it move to the left at a speed of max speed. And finally, let's assign to movement the value of move and slide the physics object in the direction of the movement vector that we have been calculating. This will make the enemy move along the direction that has been set for it. Let's see if we don't have any problem in the 2D view, and then let's run the game to see how the character will move. And we have an error. It seems that the problem is caused because when we created the script, we have correctly identified that we were inheriting from the wrong class and changed it to kinematic body, but we didn't move the script from the AnimatedSprite node to the kinematic node, and the script cannot correctly inherit from the correct class. Let's move it to the right node. Select the AnimatedSprite, and then in the inspector under the script field, click on the drop-down arrow and select Clear. This will remove the script from the AnimatedSprite. Then, to add the script to the kinematic body node, you could go through different paths, select the script and drag it on the node, or as we are going to do, select the node, and then from the script field, in the inspector, select the load option to attach the enemy skeleton script. Let's run the game. And now, the game runs correctly, but the enemy is moving in the wrong direction because we are making it moving to the left, but the sprite is looking to the right. Let's fix it. Go to the script editor by clicking on the script option on the top bar in the IDE. Go down to the move enemy function and where we were subtracting the max speed to the movement vector, so let's switch to adding. Let's quickly run it to keep checking the script. Now, we can see that the enemy is moving to the right correctly, and when reaching the end of the platform it falls to its death pulled away by our gravity. Now, let's make it aware of its environment by detecting when not anymore on the ground or when colliding with certain objects in the game level. We could do it through different solutions, but in our case, we are going to do it with two raycasts that will be checking vertically the ground and horizontally with objects in the front and on the back. To implement it, let's go to the enemy skeleton tab. And in the hierarchy let's add two new nodes. From the node selection type Raycast in the search box. Select the Raycast 2D. Rename it to Raywrite. Repeat the actions for the second Raycast and name it as Ray Down. Let's fine-tune the horizontal Raycast to make it suitable to our needs of checking if the enemy is colliding certain nodes horizontally. Click on the right ray node, and then in the inspector fine-tune the cast field. Let's increase the X component to 50, and let's reduce the Y to 0. Selected the down ray, and make sure that the values in the cast field are set as having X set to 0 and Y set to 50. Let's move it slightly forward to be in the front of the enemy to check ahead of the enemy for the ground. For the Raycast to collide with any element in the scene, or with only a subset of them, we need to define physics layers that will be able to identify each object as a set of elements that can be interacted with. To create those layers, we need to go to the options of the project by clicking on the project option on the top menu, and then the item project settings. A new dialog window with the settings for the project will open. Scroll down to the layer names options and select the 2D physics. This will load up a new interface where you will be able to see the default 2D physics layers available. You can add a name by clicking towards the end of line and introducing the game that you want for the layer. In our case, we will be customizing 3 names to default, player and enemies. We will be able to fine-tune it later on the series. Next, we need to assign each of the node's colliders to their respective physics layers as to allow the physics interactions to work as planned. Let's start by the enemy skeleton and its kinematic body 2D. In the inspector, under the collision object 2D, click on the collision option. This will open a grid with the different layers available. If you hover the mouse icon over any of the cells in the grid, it will show you the name that it has been associated with, as well as some other parameters. Assign the enemy to the layer 3 or enemy by clicking on it and clicking on the layer 1 to unselect it. Let's now change the mask. Since we want to interact with the default and player layer, let's click on the masks 1 and 2 to activate them. Time to repeat the action for the raycasts. In this case, we will have only to set the masks for which we want the physics interaction to happen by clicking on the appropriate layers. Let's start by the down ray. We will want it to only interact with the ground, so click on the layer 1. Let's also by the way enable the raycast by clicking on the enabled button in the inspector top. Let's now with the right ray. In this case we will want to interact with both the default layer which is 1 and with the player which is 2. Again let's enable it start as soon as the game starts. Now, let's replicate the same actions for the player object and let's assign it to the player layer or layer number 2. We could also adjust the layer mask but we'll leave as it is for now. Time to integrate both in the enemy skeleton script, so go back to the script editor. Let's start by adding a boolean variable moving right to track if the enemy is moving to the right or not, which would mean moving to the left. Go to the physics process function and add at the beginning of the function an if to check if the vertical raycast is not colliding with the ground, which means the raycast has reached the end of the platform and the enemy should turn back. The raycast method is colliding will be returning constantly true while on top of the ground of a platform and will return false once the raycast has no longer the contact with the ground. This is the moment where we want to turn around, so we need to invert the value of the condition to execute the actions. So, use the exclamation point at the beginning to invert the value of the is colliding method and execute the actions only when false will be returned. So, if it is the case, let's invert the value of the variable moving right with the same inverting operator. So, in the line of code where we are assigning the value max speed to the movement x, let's add an inline if, to check on the value moving right and to use either plus or minus max speed. Let's run the game to see what happens. The enemy is correctly changing its direction when reaching the end of the platform, and then it starts to push the player around. Let's now make it take decisions when finding objects with the horizontal raycast. Let's make the same check that we have done for the vertical raycast, and check if it is colliding with any object in front of it and turn around by inverting the value of the moving _right variable. The problem is that if we look at the code, we can see that it is not very optimized. We are doing the same for two different conditions. Let's optimize somewhat our code, by putting everything under the same conditions and using an OR operator to get into the group of actions either by reaching the end of the platform or by hitting an obstacle. Now, since the code is cleaner, let's also make the character flip. With the player's case, we have used the flip function. Now for this case to showcase other possibilities of doing, let's invert the X scale of the now, which will result in the node and all subnodes to flip, even the raycasts. So, let's add that scale X equals minus scale X. Let's run the game. And we can see that our enemy turns back when reaching the edge of the platform and start to go right but immediately turns back to the left. This is because our raycast is quite long. Initially, we have set it to be of length 50, so it is detecting the player from quite far. Let's adjust it. From the hierarchy pane in the enemy skeleton scene, select the right ray node, and then on the inspector, in the cast to X field reduce the value from 50 to 10. Let's run the game. And now, our enemy goes almost up to the player before turning back. It would do the same if it would be any obstacle. It is validating our behavior, but this is not exactly what we want. Because we are developing enemy artificial intelligence, so this means that we want to attack the player. For this, the first thing that we need to do is to understand what have we collided with, as to depending on the object take a decision. For this, we can take advantage of one of the methods of the raycast, which allows you to get the collider of the node that it collided with. So, let's go back to our code, and right after the condition we have just modified, let's add a new variable that will hold the object reference returned by the raycast. We are going to name it, and initialize it with the $right ray get collider. Then afterward, let's check if collider is not null or empty, which will mean that there is an actual node being returned by the raycast. As an action, for now, we will just print on the console the name of the node. Let's run the game and wait for the moment where the enemy gets near the player. Let's move the game window out of the way to allow us to see the console logs. And, we can see that each time the enemy skeleton's raycast is hitting the player, the name player is being printed on the console, so we are recognizing it. Let's go back to the code. Let's delete the print function and let's add a new condition to the first one, where we are checking if the collider name is equal to player. If it is the case, we will set the movement vector to 0 to try to make the enemy stop in front of the player in range to attack it. If not, then let's process the change of direction and then the node flipping. If we tried the game now, we would not yet know if the player is or had been in range, so we need to keep its value on a variable for further testing afterward. After the instruction where we are stopping the enemy, let's add a new instruction where we will set a variable player in range to true. Let's now go up and declare that variable in the section that we are using to define the variables and constants for our game. Initialize it with false. Now, let's go down to the move enemy function, and right before the calculation of the movement, let's add a new condition where we are going to check if the player is in range, in which case, the movement will not be calculated and will stay 0. Let's run the game again. And the enemy stops in front of the player as it is supposed to do. Nice. But we have a sliding enemy, and we are to introduce the attacks, we would not have an animation function. Let's do this now. Let's go to the enemy skeleton script and let's add a new function called animate. The first check that we will perform is to see if the enemy is moving by checking it is different from the vector 2,0. If so, then the walk animation should be played on the animated sprite. If the enemy is stopped, represented by movement being vector 2,0, then the animation that should be played, should be the idle. So, let's invoke the $AnimatedSprite player with the idle animation. Let's add the animate function before the move enemy. Time to check the results. Hit the run button. Okay. The character is walking, but the animation is very slow because as stated earlier in the video, in our case, we forgot to set the frame rate of the animation to 12. So, let's do it now. If you have already amended the problem, then skip this step. Let's run again the game. And now the animation is playing at the right speed. Since we are located in the animated sprite, let's create the attack animation and a couple of other ones for later episodes. Click on the Create Animation button, and then on the Load Sprite sheet, as we have done previously in the tutorial. Locate the attack sprite sheet. Adjust the horizontal propriety to 18 and the vertical to 1. Click the button Select All Frames and then the button Add Frames. Repeat the previous steps for the animations associated with death and hit. We will speed up the video to the end of these steps. Okay. Done. Time to move on with the attack behavior. If you don't know, maybe we can add some detail, and if not you can skip this section. In games, when you are creating battle systems that are based on closed range weapons like a sword, stick, spear, or any other weapon, we usually talk about melee combat. Melee combats have a lot of different approaches and subsystems depending on if you are fighting against one or multiple enemies. If you have different weapons with different damages or different ranges. In our case, our melee combat will be simple, we will damage all the characters that will be in the range of the weapon being used by the character who is attacking. How can implement this damage within a certain range? Very easy. Using the concept called hitbox, which is creating a geometric physics shape at a certain position away from the character and with a certain area. That shape is not created randomly or when the character starts attacking. It will only be created when the animation of the attack will reach the frame that is designed as the one that impacts the opponent. So, this means that while you are playing the animation attack, you have to count the frames of the animation to create the physics shape at the right frame, and then delete or disable it a couple of frames afterward, once the attack is no longer within the damage phase. In games, this can be done in two different ways. First, with animation events, in the attack's animation, you define an event with a callback that will execute the process of creating the physics shape, to identify all the objects inside of it, and apply damage to the ones that would be supposed to receive damage. The second option is to actively keep track of the frames of the animation and make the count and apply the process of creating and apply damage directly. In our case, since we have been using animated sprites, we will be using the second process and will count directly the frames as to call out directly all the instructions associated with the damage. In both cases, we will need a physics shape to be used, so let's create it now. In the enemy skeleton scene, select the kinematic body 2D and click on the Add Node button. In the search box, type area and then choose the option Area 2D. Hit the button Create, and when going back to the editor, you will not see anything. This is normal, we have not yet finished the process. You can see that to the right of the Area 2D on the hierarchy with an alert sign. It is complaining that the Area 2D doesn't have any collider associated with it. So, let's click on it, and then create a new collider on the scene. Click on the collision shape 2D to select it, and then on the inspector pane, under the shape option drop-down menu, choose a shape that suits your needs the best. In our case, we will choose a rectangle shape 2D. As soon as you choose it, all the alert signs disappear, and you can now see on the editor the box associated with the Area 2D. Click on it and move it to be in front of the enemy at the feet level, and slightly ahead of the character, more or less where the weapon it carries is touching the ground during the attack animation. You can also size it to make it as big or as small as you want. Once finished, set the layer of the new Area 2D to be in the enemy's layer, or number 3, and then for the mask to be interacting only with the player layer set on layer 2. Let's also set its initial state to disabled. We can also rename the collision shape to Hitbox for easier reference later on. OK, time to track the animation frames. In the inspector pane, click on the Node tab to open the signals callbacks associated with this node. Since we are on the Area 2D, we will see the list of all the functions associated with the node. Since we want the animated sprites one, let's select it from the hierarchy pane. We can see that now, we have one signal named frame change that is called on every frame of the animation being played. Select it, and on the bottom right of the pane click on the button Connect to create the callback on your code. Let's delete the pass function and add our code. Since we are going to make some checks on every animation frame, we don't want to have very expensive setups in the code, so let's cache the animated sprite by creating a variable to hold the reference at the beginning of the code. So, let's type it on readyvar animated sprite and sets it to $animated sprite. Let's do the same thing for the reference to the hitbox. In this case, since the node hierarchy is complex, let's use the getNode method with the path to the hitbox. Area 2D, Hitbox. Let's go back down to our callback function, and an if condition to check if animated sprite frame is bigger or equal than the frame where we want the damage to be produced. For now, we are going to put a 7, but we will fine-tune it later. Then let's add the last frame where we would want some damage to be happening that we will be set as 8. If it is the case, then we will activate the hitbox by setting the disabled propriety to false and add a debug text hitbox activated to see if it is working. If not, let's disable it and print the message hitbox deactivated. It seems that we have a spelling error on our animated sprite initialization. We will just copy the one we are using over the first definition. Let's run the game. And we can see in the output window how the hitbox is being activated and deactivated, which is exactly what we were looking for, but we want this to happen only for the attack animation and not for any animation being played. So, let's make the adjustments. First, let's check that the animation that is being played is the attack by comparing the value of the propriety animation with the name of our attack animation. Let's run again. We can see that since the attack animation is never played, the hitbox is never activated. This means that we need to add now an attack state where the animation attack will be triggered from. Let's go back to our physics process. Just a small remark, any code non-physics should not go into this function, but for now, while prototyping we are keeping it here to make the code clearer to follow. Add an attack function call before the animate one. Add an if to check if the player is in range and is not playing already the animation attack. Then play it. Initially, we thought that there was a function to check it, but in the end, we had to go again with the comparison with the name of the animation as played. Let's run it. And nothing happens. What could be happening? Remember that a game is running at least 60 frames per second, which means that if we are not locking states in exclusive conditions, we could be overriding any behavior with another one. This is what is happening in this case. The idle state is taking control as soon as the enemy stops and doesn't perform any action. Let's go to the move enemy function. Add a condition to test what the enemy is attacking, in which case return from the function without running any of the other instructions. Let's go to the top of the class, and let's create an initialize as attacking with false. Now, in the attack function, let's set as attack to true. To finish the attack, let's try to add an else condition where if the enemy attacks and is no longer playing the animation of attack, then set it to false. We have tried several different approaches with this condition and in the end, it was not working correctly, so we decided to use the signal associated with the end of the animations, as we will see later on the video. We decided to move to create the damage system. To perform the damage, we need to detect all the colliders that are inside the Area 2D collision shape, and for each of them check if they can suffer damage as to apply it. For this, we need to use the signal associated with the Area 2D, the body entered. Once inside the callback, the first thing that we have to check is if the object can be damaged. We can do it by checking it has a method called takeDamage, in which case we'll call it with the damage level that we want to use, which will be held in the const weapon damage initialized with the value 5. We need now to create the method takeDamage, so select the player script and at the end of the code, let's create the takeDamage function. The function is very straightforward. It will reduce the player life by the amount of damage received. Since we didn't have defined previously the life level of the player, let's do it now by creating the variable and initializing it to 100. To see what is happening, let's add also a debug text stating that the player is taking damage. Let's run the game. We can see that in the output log that the player is indeed taking some damage. But, in a not very interesting and silent way. Let's juice up a little bit adding a hit impact. Since we had already created all the animations for the player, we just need to call the code from the takeDamage function. So, in the player script, after decreasing the player life, let's add the play animation hit. Let's run the game. And we have a problem. There is an error with the line of code that we have just typed in. To avoid problems, let's copy the instruction from a previous line and paste it. Let's run again. Yes, no, we don't have any errors, but the hit animation has not been seen. We have already seen this problem with the attack. So, let's try to fix it by adding a variable as hit with an initial value of false. Let's go to physics process and in the conditions that we have already put at the beginning for the attacking, Let's fine-tune it to hold the is hit condition too. Where we currently have an else, let's modify it to a if and the player not being hit. Then add a new else whereas the player is being hit and the animation is not being played, we will set back the is hit to false. Then go to the take damage and add a new line of code to set the is hit to true. Let's run the game. The player is receiving the damage but the animation is not being reset and it stays on the last frame of hit animation. Let's try to fix it. Let's go to the 2D scene view and select the animated sprite on the player and click on the Node tab on the Inspector tab. Choose the animation finished and click on the Connect button. In the code, let's copy the piece of code that we have created early in the physics process and paste it into the new function. Let's rename the elif to if. Let's also delete the last part of the code that checks if the animation is playing as we don't need it here anymore as we are on a callback function that happens when the animation has finished. Let's run the game. And we can see that now, our enemy is correctly displaying the hit animation, but it doesn't seem to die. We have an eternal enemy. Let's address this in a fast way for now. Let's go to the take damage function and if the player life is less or equal than 0, then let's delete the overall node with the queue-free instruction. Not very elegant but very objective for now, and we will have time to address it later on in the series. Let's run the game a last time. And we can see that when the player is destroyed, the camera resets to the default camera zooming away from the scene as we have destroyed the node and all subnodes including the camera. In the next episode, we will be improving the death and integrate and allow the player to defend himself from the enemy. We will also respawn both the player and the enemies and extend somewhat the level to try to make some basic level. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.